Hello everyone, Dr. Kat here. Wanted to kind of walk you guys through how I approached this initial data analysis with all of our grades for this exam that I had you work with for last week. Now, one thing I want to make really clear, I'm not an expert in Excel. In fact, I just think it's important that we struggle together. And also, I'm just going to talk through what I'm working with. So, what I'm going to do for this short video is walk you through my thought process as if I'm first looking at my data. Okay, so let's imagine that I have downloaded this from Blackboard, which is exactly what I do. So what I'm looking at is an exam. And right now, this is as raw as it gets. Raw data just means you haven't done anything to make it make more sense. So the first thing I may want to do is just organize this from smallest to largest. So I'm going to highlight my column here, and I'm going to go sort smallest to largest. Okay, I'm going to expand my selection, and here we go. Okay, so now what's happened is I have my data that's sorted from the lowest score, which is a 71, to my highest score, which is a 100. Okay, now the first thing that I should be thinking as the teacher is I start looking at these scores and I'm like, Eliza, does that make sense? And I start thinking, well, I don't really feel like she understood this. I remember her not doing well on the quizzes, or, oh yeah, she's been sick. Or sometimes I'm like, what happened to Eliza? She's been doing really well, and all of a sudden she got a 71, which is the lowest score, right? So this is when we bring in our topic of triangulation. So initially, before I even graph anything, I just take a brief overview of my students because I know them. And I can ask myself, okay, this is an outlier, not a significant one, but Eliza's got the lowest score. Does that seem right? And by asking myself that as the teacher, in my mind, I should have an understanding of where she has been in terms of understanding this content via homework, classwork, things like that. So looking and just considering patterns, there's your fancy word for that, triangulation. Okay, so within that, I'm also just initially thinking about internal and external noise, right? So those both relate to reliability. So honestly, when I first start, the most important thing for me is internal noise. So particularly if this surprises me about Eliza, I start thinking, is she okay? Is there something going on? Or it could actually confirm my expectations of she's been acting kind of off and this definitely makes sense. I think there may be something going on with her. In that case, it kind of just provides more evidence for me to maybe have a conversation with her. Now, this happens at all levels, so I literally will just scan through and think, okay, here's Elijah, here's Keshav, here's Kit. Just a quick name to grade, right? What I would also be interested here are my 100s. So hopefully that shouldn't surprise me because I should have a good understanding of where the students are at this point. But what is important to recognize is if there's a really weird pattern, as in like all of my students did really bad, or in this case, a lot of them did really well, I might think about like internal or external noise at a more holistic level. For example, oh, this was the day of the lockdown drill. Why did I even give this assessment? Or this was right before spring break started. Okay, so I'm just kind of asking myself general questions. I like to go through this thought process before I do anything else because I'm just looking, Eliza, Keshav, just doing a quick scan. You get to know your students really well, so first I'm just doing a quick scan. Okay, the next thing that I would do is I would want to create some kind of graph, right? So when we want to create a graph, we're going to insert. I just like to go to recommended charts, and then I'm just going to see what happens. Whoa, that's not helpful. And this is why I wanted you to try and kind of suffer together, because honestly, the way that this works is trying things on your own and experimenting. Sometimes it takes making the mistakes to realize what we really need to get done. So I'm sure several of you guys did this at first. What we have done here is basically I'm just translating this exact information into a title. So it's not really, or into a chart, excuse me. It's not really helping me, right? I'm just seeing, okay, Eliza, and then I'm trying to figure out what does that equal, right? So this doesn't really help me that much, but I wanted to show you, hey, most often I accidentally make that first thing, and that's kind of just a common mistake, okay? So the mistake that's happening here, remember, this portion right here, when we have the student's name and their grade, that portion is called our simple frequency distribution. That's literally just, here's all of my students' names and their grades. That's really difficult to present graphically because I don't really care that certain people got a 97. I'm more caring about, like, where are my A's, where are my B's. So really, to get to that portion of the chart, we want what's called a grouped frequency distribution. Okay, now the cool thing about a group frequency distribution is you can make them in any way you want. Okay, so several of you guys got to this point here. So I'm just going to start over here. Let's say that for my purposes, I want to start my next class by doing a differentiated activity. So I really want to differentiate for readiness. Remember, readiness is how ready the student is on certain material, okay? So I can automatically see, dang, I got some 96s, 97s, and 100s. This group is looking really good. And then I've got a couple that seem like they're struggling. But here's the thing. I only have the ability to create 2 groups tomorrow in class. Why? Because I don't have my teaching assistant with me, or real world, I don't have a teaching assistant. And it really just makes sense for me to differentiate on 2 levels. So what I want to do is think about 2 groups. So let's say I want my students who really need help, and I think I want my students who seem, based off of this assessment, that they're good on the material and they need to move on. Okay, so actually I could just make a grouped frequency on 2 levels, right? So let's just say my lowest grade was a 71, my highest grade is a 100, right? So I have from 71 to 100. That's my distance between the lowest and the highest score, right? You can get Excel to calculate all this at one time, but let's just look at my range. That would be the difference between my highest and my lowest grade. So my range is 29, okay? So that tells me a lot. What I'm most concerned about are probably the students who have like a C or lower, okay? So one thing that I could do is I could just sort my students based off of let's see, 83 or lower, and then 84 and above, right? And again, guys, I'm just walking you through. This won't create a pretty distribution, but this is a good example of things I may do with my data. Okay, now this is a small data set. Let's be real, I'm just counting, right? So I'm starting with 71 and up to my 83. Now, here's a good little trick for you. Instead of me saying 1, 2, 3, 4, 5, 6, you can look down here and Excel says count. Count is 6. So 6 of my students were 83 or lower. And then I can go from Zach down to Anna. My count down here, 19 of my students were 84 and above, right? So I guess I could create a graph. It's not really needed in this case. So recommended charts, sure. It's literally not telling me that much. This isn't really a distribution because I'm only creating 2 groups, right? So I can see I will have a smaller group for that need help group, which is good on me as the teacher. And then I'll have a larger group for good on the material and need to move on, right? So I'm going to go ahead and get rid of that. So this is great. This shows me I have a restriction in terms of real life. I've got 2 groups I can use. So this is just one way I could react to the data and think, all right, if I had to split them up into 2 groups, I think maybe C or lower is good for me to give some special help to. And really, 88 or above, they seem to be good on the material. Let's move on. Okay, now let's think of another example. Let's say I'm interested in what my grades are in terms of my distribution of A's and B's. Okay, so again, this can look different depending upon the school where you work. They may define A minus, B differently. Usually what I like to do is just think of the range of scores. So in this case, I'm just going to do, my lowest was a 70, so I'm just going to go ranges of 5. I'm going to do 70 to 75. Actually, this always gets me. 70 to 74, 75 to 79, 80 to 84, 85 to 89, 90 to 94, 95 to 100. Now, the beauty is you have, as the teacher, the power to decide this on your own. This is not Winthrop's grading scale. However, I like to do intervals of 5 because it helps me see, in my opinion, there is a difference between this like 95 to 100 and 90 to 94. Typically, if I'm presenting data to the students, then I will organize this based on the grading scale wherever I'm working. So this would usually, for our purposes, I would organize that by Winthrop's grading scale. Okay, so again, this is a small data set. There are ways that we could get Excel to transfer this information over. Okay, so we could do that. But again, the reason I kind of like to do this by hand is I'm constantly looking at that child's name. So as we're analyzing data, we always want to think about whose data are we working with. So something about counting it for myself actually really helps me, okay? So I've only got one student who is in that 70 to 74 range. So I'm just going to put a 1 right here. Now 75 to 79, I've got Keshav and I've got Kit. Let's actually do it this way. Keshav and Kit. Obviously that's 2, right? But again, down here Excel will tell me 2, which is helpful if it's a larger data set. Okay, 80 to 84. Okay, so I'm highlighting, looking at my, count down there is 3. And as I'm doing that, I'm thinking 80 to 84. We got Michael, Maz, and Kristen, right? That should be kind of telling me something. You can be thinking about those students. You can be triangulating, considering what their other data has shown. Okay, 85 to 89. All right, we've got Zach and Paul, so that's just 2. 90 to 94. Okay, there's 4. And let's look at 95 to 100. Okay, so Adri down to Anna. Now again, 1, 2, 3, 4, 5. It's hard to count. So instead of asking yourself to count that, simply go right here, count. So that's going to be 13. Okay, now a couple of things you can consider. Let's just say that Anna, unfortunately, is not typically a very good student, but Ashley is. And you've noticed that Anna and Ashley spend a lot of time together. They're really good friends, and they were sitting next to each other during the test. Now, we don't have this deficit perspective of what if Anna was cheating, right? But you can go to your triangulation if this has been a problem before. That will kind of help me, right? So let's go ahead and chart this. So what we've done here is create your grouped frequency distribution. So the difference is your simple frequency distribution is here are my students and here are their grades. Literally, I downloaded that from the grade book. Group frequency distribution is when I group them to make more sense. So you can group them in any way. A lot of times I'll see my students always group based on the grades of like A minus, B, but then they can only differentiate for 3 groups. So my reaction is typically group students based on your teaching goals, right? So if you want to differentiate for readiness and you happen to have, let's say, a Winthrop candidate coming in, and you know that you have the ability to have 3 groups because you can have 2 teacher-led groups and 1 independent group, then let's group those students in groups of 3, right? But it is important to recognize that as we're creating this group frequency distribution, it doesn't always have to look the same. It just needs to serve you the purpose in terms of teaching. Okay, so now I'm going to highlight this, go to Insert, and I'm just going to click Recommended Charts. And what in the world happened? Okay, so let me look on what's going on here. Looks like for some reason they have scattered everything very close to each other. So guys, I have no idea what happened. So what I'm going to do is I'm just going to click around here. What's happening? Let's see. I don't really care about the format. Let's see if I can find format chart area, reset to match style. No idea what that did. Guys, you see how I'm struggling? This is the reason why I have not practiced any of this. I think it's really important that you give yourself the opportunity to fail a little bit. Okay, so one thing I'm wondering, maybe it's because I highlighted, let's try this. May have been because I highlighted this whole column. So let me try this and see what happens. Insert, I'm going to go to my recommended charts. There we go, right? So what I did originally is I went like this, and I think that Excel wanted to try to graph all of this empty data. So what I did instead is I just highlighted the portion that I wanted. Okay, so Dr. Cat struggles too. All right, so here we go. This is our frequency distribution. I can go in here and update things. I could write exam grades, right? If I wanted to, I could go in and label range and the number of students, right? So to me, this graph is really, really helpful because it's helping me see where the majority of my students are, okay? So basically, most of my students did really well. So that's a good thing, right? When we talk about types of distributions, we talk about a negatively skewed distribution, a normal distribution, and a positively skewed distribution. Okay, so these terms can get confusing, so just bear with me for a second. Absent of this, don't think in your fancy terminology yet. Let's just look at our exam grades. So we have the lowest, 70 to 74, and the highest, 95 to 100. Now, first notice, I don't have anything below a 70. So when you're creating these, you can choose to start at that 70. Another thing I've seen students do is they start at 0 and then their actual graph doesn't start till like way over here. Okay, so what does this tell me as the teacher? It tells me the majority of my students did well. So that's good. I want the majority of my students to do well. When we think about a distribution, we always name the distribution based on the tail of the graph. In other words, the tail tells the tail. I told you guys that if you were in my EdCo 220 class. Okay, so the tail of this graph, it seems to be following this kind of like upward movement. So the tail is right here. And that tail, is it more negative or more positive? It's more negative. So that is going to be described as a negatively skewed distribution. Okay, so the reason this is so important when you start thinking about one student, let's consider, well, if your student scored a 100, that's great. It tells you a lot about that student. But within the context, it also tells you that the student is pretty much along the same pattern as the rest of the class. Now, if your student, your focus student, happened to be Eliza down here, that would tell me that your student is performing quite differently than most of the other students in the class. Okay, so let's imagine that your focus student has a grade of, let's say their grade is a 78. Okay, so let's walk through this in a couple of ways here. Your student has a grade of 78. Right here we have a negatively skewed distribution. That grade of 78, it's definitely on the lower side in comparison. So that does tell me that I want to make sure I'm working with that student. I'm not as concerned if they were this lower grade right here, but definitely looking in the context of the frequency distribution, I definitely want to give that student some extra help. Now, let's change this up a bit. Let's say that this is our distribution. Let's see. What's my sum here? Okay, so what I've done, I just highlighted all of the counts. Look down here. That means I have a count of 6 cells. So 1, 2, 3, 4, 5, 6. Now this is beautiful. The sum of those cells is 25, right? So the reason I wanted to do that is I want to keep this sum as 25 for this next illustration. All right, so let's say that this is actually 5, this is 3, this is 4, 1, 2, 2. Okay, now let's see here. All right, my sum is 17 down here. I'm just playing with data. So how much do I need to get to 25? I need 8 more, so I'm just going to do 5 there and 2 there. Now where am I? 21. Man, Dr. Cat does know how to add, I promise. All right, so I need 4 more. I'm going to do 5 and 7. Okay. Here we go. 25. Now, well, this is my fiance telling me we are looking at a house today, if you're wondering. And yes, it is on a road called Princess Drive. This is your true look at Dr. Cat's life. Okay, so notice what happened. The frequency distribution, guys, it changed. This is the beauty of Excel. As I changed this information right here, the chart already updated for me. So this is a kind of weird distribution going on. Most of the students did pretty poorly, and then we had a group that did pretty well. So actually, I wouldn't call this negative, normal, or positively skewed. Here's a bonus. I would call this a bimodal distribution. Why? Because it seems to have 2 modes, the lower and the higher. Okay, so what I want to focus on is now you would interpret your focus student differently, wouldn't you? Now that grade of 78 seems kind of common. So as you are thinking about how to serve that student, you'll think how to serve that student differently because their grade isn't as concerning because the rest of the class, a large majority of them, didn't do so well. So this is why I think it's so important to first get a holistic view of how your students did. Okay, now just a couple of other things that you can play around with. If I highlight my grouped frequency distribution here, yes, you can do your recommended charts. Oftentimes I do this because Excel is smart, right? Another one that's helpful is this bar chart, or I'm sorry, this pie chart right here. This is just another way to visualize the data. So depending upon what is most helpful for you, sometimes I like to give students this data if for some reason they want to know kind of the breakout of the class. I tend to resist that though because I don't want my students to be comparing themselves to each other. But again, it's very simple to create a chart, a pie chart of the same information. And let's just kind of play with some numbers. See how everything's changing. It's very satisfying. Okay, so that's really helpful. Just to let you know, actually this bar chart, that's kind of your formal frequency distribution chart. When we consider frequency distribution, we think of it in these terms: negative, normal, and positively skewed. So for EdTPA, I would chart it like this and call it negative, normal, or positive, maybe bimodal. And then you could also represent the same data here. Okay, so this, great illustration of UDL. You can represent the data in certain ways. Okay, so since I'm in Excel, I just want to show you one more thing. What I could also do, and this is what I'm more apt to do if I'm actually using this in the classroom with my students. Now this, guys, I do this all the time. For pretty much every big assessment I give, I at least get to this group frequency point, and I like to graph it. So I'm going to show you something else you could play with. Let's say that I want each of my students to do this. So I'm going to give, let's see. I'm going to give 10 quizzes throughout the semester. And each time my students get their quizzes back, I am going to require them to input their grade. Okay, so I'm going to do first quiz, you got a 70, then you got an 80, a 65, a 95, a 100, a 90, an 85, a 70, 70. Actually, let's just do the first couple here. So let's say you're having your students chart their grades. You could do this in Excel. So what I want to show you is I could just do insert recommended charts. And I've had students do this before, where they kind of trace how well they're doing, particularly if a student's having trouble with kind of a very fixed mindset. I like to have them do this. If you're working with older students, it's actually a really good tool to teach them how to use Excel. If you're working with younger students, what a great way to bring in your math standards. I have done this with a bar graph that students are filling out on graph paper. Okay, so just a note that using grade analysis is actually a great way to simultaneously reach some of those math standards. And also that's important for self-regulation and for growth mindset. Okay, so everything's going together. All right, so that is your brief view into Dr. Katz's mind. Again, this is how I would look at initially the student grades for an exam. So sometimes I will download from Blackboard, which is our learner management system. Sometimes I'll download more than one grade. For example, I like to look at like quiz grades all together. It is really important to do that so you can kind of bring in that triangulation and see where students are otherwise. But this is realistically what I do with a large-scale assessment like an exam, something I'll spend some really intent time during class to analyze. I would not do this for homework. I may not even do this for a quiz. What determines if I go through this analysis is my teaching goal. Okay, so it's all based on that goal. If I know I can differentiate for the next week on readiness because I have more helpers in the classroom, I'm doing this every day, right? So it depends on your goal as a teacher. Okay, so hopefully you've seen me struggle a little bit and that helps as we move into class or data analysis more at a student level. I'll kind of pick up and let you know what I would do next. All right, thanks guys.